everyone, this is Babitha, working as Assistant Professor in the Department of EC in Institute of Aeronautical Engineering. In this session, I am going to discuss about problems related to the common emitter configuration of the transistor. So before going to the problems, what are the parameters we need to going to calculate in the case of transistor common emitter configuration? We'll see. So in this session, we are going to calculate all the parameters of the common emitter amplifier here. In that, first one is calculation of the input impedance, and next calculation of the voltage gain, and how to calculate the output admittance of the amplifier, and the overall voltage gain including the source resistance, and the overall current gain including the source resistance, and overall power gain, how much that particular common emitter amplifier can able to provide. So these are the parameters we are going to calculate in the coming problems. So for calculating those parameters, first of all, we have to go with the AC analysis of the given circuit. Okay. So how we can able to perform that AC analysis of the transistor circuit? So first thing, we have to draw the given circuit diagram or actual circuit diagram that may be in any configuration, common emitter configuration, or common base configuration, or common collector configuration. So the given problem, we have to take it as actual as it is with all the elements, all the resistances as well as all the capacitances, and along with the input output signals we have to indicate on the actual circuit diagram. And after that, to draw the small signal equivalent circuit, or in order to do the AC analysis, we have to replace all the coupling capacitors as well as bypass capacitors which are present in the circuit by short circuit here. Okay, coupling capacitors means across the input as well as output, we will utilize two coupling capacitors. So the input capacitor is used to couple the input signal to the base of the transistor in the case of common emitter configuration, and one more capacitor across the output side that is connected to the collector terminal of the transistor to the output. So that function of that coupling capacitor, output coupling capacitor, is to couple the output signal to the output terminal of the transistor or common emitter transistor here. For example, here I am taking the common emitter circuit with all relevant resistances and biasing network also. So here we are providing the supply voltage, and this is the collector resistance, and this is the emitter resistance, and this is the base, collector and emitter terminals of the common emitter amplifier. And here these two are the R1 and R2 resistances which are used to provide the proper biasing for the amplification, and the input signal through the coupling capacitor Ci we are providing to this circuit. Okay. And similarly, the output across the collector of this circuit through the output coupling capacitor we are connecting to the output. So this is the common emitter amplifier circuit. This is the actual circuit diagram. So in this particular circuit, we have to replace, along with this, we are also having the bypass capacitor Ce here. So total 3 capacitors are present. So in order to draw the AC equivalent circuit of this one, we have to replace all the coupling capacitors. This one, and the bypass capacitor, emitter bypass capacitor by short circuit. We have to short all these capacitors here. Okay. So if we short all these capacitances, we will get the circuit. I'm drawing here. So now we are having only resistances in the circuit. Why? Because we are shorting all the coupling as well as bypass capacitances. R1, R2, RC as well as RD resistance. So this is after second step, we will get this particular circuit. And next, replace DC sources by a short circuit, or else we have to make VCC as ground here. Why? Because we are going for the AC analysis, that's why we should not consider the DC signal into consideration. So that's why we have to make it as ground. That is our third step. And in the fourth step, we have to mark all the terminals of the transistor. We are having 3 terminals of the transistor. Though it is the common emitter configuration, I am taking emitter below here and base collector. Okay, base is the input terminal, collector is the output terminal, and emitter acts like a common terminal between the base and collector here. Okay, so here we are taking the circuit in this way, and we have to indicate whatever the elements which are connected to all these terminals, so that it will becomes the H parameter equivalent circuit or else AC equivalent circuit. So for this particular common emitter configuration, if we draw the H parameter model or AC equivalent circuit, we will get it as first H parameter, HIE input impedance, and here we are having HRE BC reverse voltage gain into output voltage, and this is input side. This section is input side. Here we are providing the input voltage VBE and the current IB is flowing here. So this is the base terminal and this is the emitter terminal, and this total thing is the input side. So while coming to the output side, we are having the current source, that is HFE into IB. Okay, forward current gain into input current IB. And along with this, we are also having the output resistance 1 by R0. And here we will measure the output voltage VCE, and the current, collector current IC is the output current. So this is the collector terminal. So this is the AC equivalent circuit of the common emitter amplifier. We can also call it as hybrid equivalent model or H parameter model. So for any circuit, we have to replace it with hybrid equivalent model in order to find any parameter. So to find that parameters, what are the formulas we required here? It is we are going to calculate 4 parameters here. That is current gain. AA is HFE forward current gain divided by 1 plus HOE into RL. This is to calculate the current gain of the amplifier circuit. And next parameter we need to calculate is input impedance. RA is HIE plus HRE AA into RL. If we substitute the value of AI here, we will get this particular formula. We can utilize this one or else this one in order to calculate the input resistance value. And if you want to calculate the input resistance along with the source resistance, we have to take the parallel combination of input resistance as well as base resistance. And next parameter is voltage gain, that is current gain into load resistance by input resistance. And the output resistance formula is source resistance plus input impedance by source resistance plus output admittance, and the variation of H parameter value. So the variation of H parameter value is the difference of all the H parameters here. So in order to solve the problems in any configuration of the transistor, we have to remember all these formulas. Okay, so along with that formulas, we also require the H parameters in the 3 configurations. Okay, the 4 H parameters: input impedance, reverse voltage gain, forward current gain, and output admittance. So the values of these parameters in the common emitter, common collector, and common base configuration. So these values also we need to remember to solve the problems along with the formulas. And when we are solving any given circuit, whether we need to go for the approximate analysis or exact analysis. So what is mean by this approximate analysis and exact analysis? So generally if we take any transistor circuit or any amplifier circuit, if we analyze that particular circuit directly with the H parameter model, it will take so much time because it is very lengthy process to calculate all the 4 parameters. So it will take very much time to calculate that 4 parameters. If we go for the exact analysis, exact analysis means we are not doing anything for that H parameter equivalent circuit. Directly we will consider that H parameter equivalent circuit and will solve all the parameters. But while coming to the approximate analysis, so in this approximate analysis, we will remove the reverse voltage gain as well as output admittance parameters. So if we remove these 2 parameters means we can able to simplify the analysis here. But at what condition we can eliminate these 2 parameters? So whenever the output admittance as well as the load resistance value, if we take the multiplication of these 2 values, if we get this particular value as less than 0.1, if this particular value is less than 0.1 only, we need to go with the approximate analysis. This one I have already discussed in the previous sessions, but just for solving the problems, I am revising it. So if it is less than 0.1, we have to go for the approximate analysis. If this particular value is greater than 0.1 means we have to go with always exact analysis. So what are the formulas I have mentioned in the previous slides? Those are applicable to the exact analysis here. So if we go with the approximate analysis, the formulas were modified here. So these are the formulas for the approximate analysis of the H parameter circuits. So the current gain is approximated as minus HFE here. In the previous case, it was minus HFE into remaining H parameter values also, but in the approximate model, it is simplified to minus HFE. And input resistance value is approximately equal to the input impedance of the H parameter circuit. And the voltage gain is minus HFE into load resistance by input resistance HI. And the output resistance is almost equal to the load resistance. So in the approximate model, we need to utilize these particular formulas instead of exact model formulas. So depends upon HOE into RL value, we need to go for either approximate model or exact model. So before solving the parameter, first of all, we have to find that particular value. So now we'll go with the problems. In the first problem, it is common emitter circuit has the following components given as R1, R2 resistances as 27 kilo ohms and emitter resistance is 5.6 kilo ohms and the load resistance value is 47 kilo ohms and the source resistance given as 600 ohms. And along with these parameters, they also given the H parameter values HIE 1 kilo ohm, HFE 85 and output admittance is 2 microamp per volt. So from this we need to calculate all the 4 parameters of the amplifier. So though they mentioned here it as the common emitter circuit, so I am drawing the common emitter amplifier circuit here. With the collector resistance and emitter resistance, and they are giving it as R1 and R2 values, means it is utilizing the voltage divider biasing. Instead of like this, they given it as RB, means that is the fixed bias circuit. So depends upon the given values, we have to understand whether it is which type of biasing. So in this case, it is the voltage divider biasing circuit. Okay, this is VCC. We are providing here R1, R2. Here we'll provide the input signal and here we'll measure the output signal. This is base, collector and emitter terminals. Okay, this is the common emitter amplifier circuit. Okay, and the given parameters here it has R1 equal to 27 kilo ohms, R2 is also 27 kilo ohms, and RE equal to 5.6 kilo ohms, and load resistance is 47 kilo ohms, and the source resistance is 600 ohms. And the H parameter values are HIE equal to 1 kilo ohm, HFE equal to 85, HOE equal to 2 microamps per volts. So these all are the given parameters. So here we need to find the parameters: current gain AI, input resistance RI, voltage gain AV, and output resistance R. So we need to find all these four parameters. So I have already mentioned, whenever we are finding the parameters of amplifier, first of all we have to replace this particular circuit with the AC equivalent circuit or H parameter model. So now I am drawing the H parameter equivalent circuit of this one by utilizing the given parameters or given elements. So here we are having first, I am drawing the H parameter model first, HIE. This is HRE VCE, and this one is HFE IB, and here we are having the output resistance. So this is base, collector and emitter terminals of the transistor. So this is the hybrid equivalent circuit of the transistor. So along with this, we are also having the remaining elements to the circuit. Those are R1, R2 resistances as well as source resistances. So first of all, I am drawing the R1 as well as R2 resistances. Both are in parallel. That is nothing but this is 27 kilo ohms. That is R2, and R1 is also 27 kilo ohms. And we are also having the source resistance RS is equal to 600 ohms. So through this source resistance, we are providing the input signal Vi to this amplifier. Okay, so across input side, we are having these particular elements, and across the output side, we are having only the load resistance R. And here we will measure the output signal across the load resistance R. So here the collector current will be flowing, and through this RL the load current will be flowing, and across the input side the base current will be flowing. So this is the hybrid equivalent circuit of CE amplifier or common emitter amplifier. We can also call it as H parameter model. Of the CE amplifier circuit. So now from this circuit we will calculate the asked parameters in the problem. So first of all, before calculating the parameters, I have already mentioned whether the given parameters we have to calculate by using the exact model or by using the approximate model. So to know that from the given parameters, I am calculating HOE into load resistance value. So the value of HOE is given in the problem as 2 microamperes per volts. That is nothing but 2 into 10 power minus 6 into load resistance value is 47 kilo ohms. So 47 into 10 power 3. So we can write it as 2 into 47 into 10 power minus 3. So if we simplify this, it has 0.094. Okay, so the value of HOE into RL is 0.094. So this particular value is less than 0.1 here. Okay, this particular value is less than 0.1. So that we have to analyze these parameters or this particular circuit by using the approximate analysis. Why? Because this is the condition to go for the approximate analysis. The HOE RL value should be less than 0.1. So here we know the formulas for the exact analysis as well as approximate analysis. So now I am going to utilize the formulas of the approximate analysis to find the given parameters. So the first parameter we need to calculate here, it is current gain. So in the case of approximate model, the current gain formula is minus HFE, that is directly equal to the forward current gain of the H parameter model. So it is already given in the problem, HFE value, that is 85. So the value of current gain is 85 here. So current gain AI equal to minus 80. And the next parameter I am going to calculate here, it is input resistance RA. So the input resistance RA in the case of approximate analysis is directly equal to the input impedance of the H parameter model, HI. So the value of this one is 1 kilo ohm. So the input impedance is 1 kilo. And the next parameter we need to calculate here, it is voltage gain. Voltage gain AV is equal to current gain AI into load resistance by input resistance. So input resistance value just we have calculated, and the current gain value also we have calculated. Just substitute that current gain value, that is minus 85 into load resistance is 47 kilo ohms, and the input resistance is 1 kilo ohm. So if we simplify, we'll get it as minus 3995 as the voltage gain here. And the next parameter we need to calculate here, it is output resistance or output impedance. So the output resistance R0 generally for the common emitter amplifier is infinity. But in the output circuit, along with this output impedance, we are also having the load impedance. So we have to take the parallel combination of this output resistance as well as load resistance. So what is the result we are going to get? That is the final output impedance of the circuit. So that one I am taking here it as R0 dash, that is the parallel combination of this R0 and load resistance R. So R0 value is infinity and the load resistance value is 47 kilo ohms. So always if you take the parallel combination of two unequal resistances, the result is the lowest value. So if we compare infinity with the 47 kilo ohms, the lowest value is 47 kilo ohms. So the R0 dash value is 47 kilo ohms. So in this way we need to calculate all the parameters using the approximate analysis. Once we satisfy the HOE RL value should be less than 0.1. So while coming to the next problem, it is a CE amplifier has the H parameters given by HOE equal to 100, output admittance, and reverse voltage gain is 2 into 10 power minus 4, and the forward current gain is 50, and the HOE value is 25 micromhos. If both the load and source resistances are 1 kilo ohms, determine current gain as well as voltage gain of this given circuit. So here the given parameters I am writing HIE equal to 1000 ohms. This is HIE, actually it is 1000 ohms, and HRE equal to 2 into 10 power minus 4 moles. Sorry, reverse voltage gain, no units for this. And forward current gain is 50, and HOE equal to 25 micromoles. So these are the given parameters, and along with this they also given the source resistance value as 1 kilo ohm, and the load resistance value is also 1 kilo ohm. So from this we need to calculate the current gain as well as voltage gain. So here again we have to take the equivalent circuit, hybrid equivalent circuit by using these parameters. So this is HIE, HREBCE, HFEIB. This is 1 by HOE. And along with this, we are also having the source resistance, and here we are applying the input signal, and we are also having the load resistance RL, and we'll measure the output voltage here. This is base, collector and emitter terminals. So this is the circuit for the given problem, and from this we need to find the parameters. But before going to calculate the values, first of all, whether we have to see the given circuit, we need to analyze with the approximate model or with the exact model. So for that purpose, I am doing HOE into RL value. So HOE value is 25 micromoles into load resistance value is 1 kilo. So if we simplify this one, we will get it as 0.025. So this value also less than 0.1. So we need to go again for the approximate analysis only. Approximate analysis of the circuit. So the first parameter we need to calculate here, it is current gain AI. So the formula for current gain in the approximate analysis is minus HFE. That is minus 50. HFE value given it as 50. So AI value is minus 50. And the second parameter is voltage gain AB is equal to AI into load resistance by input resistance. So current gain value is minus 50, load resistance is 1 kilo ohm, and the input resistance is also 1 kilo ohm. So this value also we are getting here it as minus 50. Why I am taking RA value as 1 kilo ohm means RA is nothing but HIE only. So HIE value is 1 kilo ohm. So because of that reason, I have substituted it as 1 kilo ohm here. So the voltage gain value here it as minus 50. So both the current and voltage gains are minus 50 here. Why we are getting minus sign? Here it is means in the common emitter configuration, output voltage is 180 degrees phase shift with the applied input signal. So that's why always in the gain we will get the negative sign. So next problem is a common emitter circuit has the following components. Load resistance is 47 kilo ohms. Source resistance is 600 ohms. The transistor parameters are HI equal to 1 kilo ohm, HFE is 85, and HOE is 25 microamps per volts. So determine all the transistor parameters or amplifier parameters here. So for this, first of all, we have to draw the circuit. of the common emitter circuit. This is the collector resistance, emitter resistance, and here we are utilizing again the voltage divider biasing. So that's why it is R1, R2. Through this we are providing the input for the base of the transistor. Through capacitor and through source resistance Rs, we are providing the input signal Vi. So this is connected to the supply voltage, and here we will measure the output voltage across the collector terminal. So this is the circuit for the given problem, and next we will write the given parameters and what are the parameters we need to calculate. Load resistance is given as 47 kilo ohms and the source resistance is given as 600 ohms, and the input impedance is given as 1 kilo ohm, and the forward current gain HFE is given as 85, and the output admittance HOE is given as 25 microamps per volts. Next, from these parameters we need to calculate the current gain AI, input resistance Ri, voltage gain AV, output resistance R0, and voltage gain along with the source resistance, current gain along with the source resistance. So these are the parameters we need to calculate from these given parameters as well as from this circuit. And I have already mentioned before going to the calculation, we have to check whether we need to go for the approximate analysis or exact analysis. So for that purpose, we need to check the value of HOE into load resistance. So HOE value is given as 25 micromos, 25 into 10 power minus 6, and the load resistance is 47 kilo ohms. So if we calculate this one, we will get it as 1.175. So this particular value here, it is greater than 0.1 here. So once this particular value is greater than 0.1 means we need to go for the exact analysis. So that's why in order to find the parameters or gains and input output impedances, we have to utilize the formulas of exact analysis here, not the approximate analysis. Whatever the problems we discussed till now are belongs to the approximate analysis, but this one is the exact analysis here. So the first parameter is current gain AI. So in the exact analysis, the formula for current gain is minus HFE by 1 plus HOE into load resistance, forward current gain divided by 1 plus output admittance into load resistance. In the case of approximate model, it is directly equal to the HFE value. Why? Because in the approximate model, we will not consider this HOE value. So that's why this total denominator term will be minimized or reduced here. So here, substitute the values of all the parameters. HFE value given it as 85, so minus 85, and 1 plus HOE value is 25 into 10 power minus 6, and the load resistance value is 47 kilo ohms. So if we simplify this, we will get it as minus 39.08. So this is the current gain for the given circuit. And the second parameter is input resistance Ra. Input resistance Ri is equal to input resistance of the H parameter model HIE plus HRE into current gain into load resistance. So this is the formula for input resistance. So now substitute all the values of Ra here. HIE is 1000 plus HRE value is 2.5 into 10 power minus 4 into current gain. Just now we have calculated, that is minus 39.08 into load resistance is 47 kilo ohms. So if we simplify this, we will get it as 540.81 ohms. So this is the input impedance of the circuit. And the next parameter we need to calculate here, it is voltage gain. Voltage gain AB in exact analysis is AI into RL by RA only. So in this case we can substitute here it as minus 39.08, that is the AA value, and the load resistance is 47 into 10 power 3, and the input impedance is 540 into 81. So after simplification it is minus 3.39 into 10 power 3. That is the voltage gain. And next we need to find the output impedance. To find the output impedance, we cannot do it directly. First of all, we have to find the output admittance. Then if you take the inverse of that output admittance, we can able to get the output resistance here. So for that purpose, I am taking the output admittance Y0 is equal to HOE minus HFE into HRE divided by HIE plus source resistance. So this is the formula for output admittance. Now substitute the values in this. Y0 is equal to HOE value is 25 into 10 power minus 6 minus HFE value is 85 and HRE value is 2.5 into 10 power minus 4 and HIE value is 1000 ohms plus source resistance value is 600. So here we will get it as 25 into 10 power minus 6. If we simplify it, we will get it as 85 into, after simplification of this particular term, we will get it as 13.28 into 10 power minus 6. So it is 11.72 into 10 power minus 6. The admittance value is. So from this, the output resistance R0 is equal to 1 by Y0, that is 1 by 11.72 into 10 power minus 6 is nothing but 85.32 kilo ohms. So this is the output resistance. But if we find the overall output resistance of the circuit, this is from the transistor itself. But if you want to find the total amplifier output resistance, that is the R0 dash. I have already mentioned it is the parallel combination of R0 and the load resistance. So here it is, R0 value is 85.32 into 10 power 3 into load resistance is 47 kilo ohms and 85.32 into 10 power 3 plus 47 into 10 power 3. So if we simplify this, we will get it as 28.36 kilo ohms. So this is the R0 dash, the overall impedance of the circuit. And next we need to calculate the current gain with source resistance. AIS is equal to load current by source current into emitter current by collector current. So this load current by source current is nothing but the current gain here. But to calculate the IE by IC value, I am taking the resistances in the circuit. This is source resistance and this is input resistance, and here the source current is flowing and here the input current is flowing. In this case, in this current is the emitter current. So I can write this IAS is equal to AI into IE by IC. This term I am replacing with current gain, and to find IE by IC from this circuit we will get it as source resistance, opposite resistance by total resistance, RS plus RI. So here if we find the overall current gain, AI is equal to AI into RS by RS plus RL. So current gain value here it is minus 39.08, and the source resistance value given it as 600 ohms, and the input resistance we have calculated here it as 540.81, and again source resistance is 600. So after simplification we will get it as minus 20.5. So this is the current gain with source resistance into consideration. And the last parameter we need to calculate here it is voltage gain with source resistance. We need to follow the same procedure how to calculate for the current gain. So in this case it is V0 by Vs into VE by Vs. So here V0 by Vs is the normal voltage gain. We need to find VE by Vs. So this one I am writing here it as voltage gain, and it is VE by Vs. So again from the same circuit we can find the voltage Rs, Re, and here IE and Is currents are there. So instead of current we are calculating the voltage now. That is VE by Vs value we will get here it as input resistance by Rs plus Ra resistance. So total AVS value is AV into Ra by Rs plus Ra. So substitute all the values. The voltage gain value we have already calculated. We got it as 3.39 into 10 power 3 into input resistance is 540.81 ohms. Source resistance is 600, and again input resistance is 40.81. So if we simplify it, we will get it as minus 1.60 into 10 power 3. So this is the voltage gain by considering the source resistance into consideration. So in this way we need to find all the parameters using exact analysis. So while coming to the next problem, a transistor used in CE amplifier has the following set of H parameters. So the given parameters I am writing HIE equal to 1 kilo ohms, and reverse voltage gain HRE equal to 5 into 10 power minus 4, and the forward current gain HFE equal to 100, and the output admittance HOE equal to 2 into 10 power minus 5 mhos, and the source resistance is 15 kilo ohms, and the load resistance is 5 kilo ohms. So from this we need to calculate the input impedance, output impedance, as well as voltage gain and current gain. So we need to find all these parameters from the given problem. So before going to solve the problem, first of all we have to find the value of HOE into RL to check for exact analysis or approximate analysis. So HOE value is 2 into 10 power minus 5, and the load resistance is 5 kilo ohms, 5 into 10 power 3 here. So if we calculate this approximately we will get it as 0.1. So it is equal to 0.1. It is almost equal to if we compare it with the HOE RL 0.1, it is equivalent to 0.1, so that we need to go for the exact analysis only. If it is less only, we need to go for the approximate analysis. So again we need to use the exact analysis formulas to calculate the given parameters. So for that, first of all I am taking the current gain AI is equal to minus HFE by 1 plus HOE into RE. This is a formula to calculate the current gain, and substitute the values here. Minus HFE value is 100. 1 plus HOE value is 2 into 10 power minus 5 into load resistance value is 5 kilo ohms. So we will get it as minus 90.9 current gain. And the second parameter we need to calculate here, it is input impedance. Input impedance Ri in the exact analysis is HIE plus HRE into current gain into load resistance. So HIE value is 1000 plus HRE value is 5 into 10 power minus 4. And the current gain just now we have calculated minus 90.9 into load resistance is 5 kilo ohms. That is nothing but, after simplification, we will get it as 772.75 ohms. This values. And the next parameter is voltage gain AV. In the exact analysis, voltage gain formula is current gain into load resistance by input resistance. So current gain value is minus 90.9 and the load resistance value is 5 kilo ohms and the input resistance is 772. It is 772.75. 772.7. So if we simplify it, we will get it as minus 28.8 is the voltage gain value. And the next parameter we need to calculate here, it is overall voltage gain. That is source resistance into consideration, AVS is equal to AV voltage gain into input resistance by total resistance, RA plus RS. So the derivation for this we discussed in the previous problem, so that's why I am directly taking the formula here. So AV is minus 5.88 into input resistance is 772.75 and again it is 772.75 plus source resistance is 15 kilo ohms. So it is minus 28.8. AVS is the minus 28.8. And the next parameter I need to calculate here, it is overall current gain. AIS is equal to AI into source resistance by input resistance plus source resistance. AI value is minus 90.9. Source resistance is 5 kilo ohms. Input resistance is 772.75 ohms. Plus again source resistance is 15 kilo ohms. So if we simplify, we will get it as minus 86.4. So this is the overall current gain. So in this way, we need to calculate the H parameter value, by utilizing the H parameter values of the amplifier circuit, we can able to find all the amplifier parameters, that may be the current gain, voltage gain, input impedance, output impedance, and overall voltage gain and overall current gain by utilizing exact analysis as well as approximate analysis in the case of common emitter configuration. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.